This is the second part of the video where we solve a system of 3 equations, and we're using primarily elimination. At the end of this, we're going to get a system of 2 equations, 2 unknowns, and that we can use a combination of elimination and substitution, and then we will simply back substitute until we find the value of all 3 variables. All right, we've already found that if we combine equation 1 and equation 2, we get equation A, and you notice that Z has been eliminated. We will now continue to eliminate Z from a second pair. This pair is going to be equation 1 and equation 3, the red and yellow equations. So we ask ourselves the same question. Choose a pair of equations, one of which is your pivot. Equation 1 was our pivot. Multiply each by an appropriate amount, usually different, so that coefficient of the variable from step 3, Z, is equal in value but opposite in sign. They're already opposite in sign, but they need to be equal in value. And so we have a 1Z there, we have a 4Z there. We need to multiply the top one by 4. I don't want that color. So we're going to multiply equation 1 by 4, and we are going to add that. And I'm going to put this up in light blue just like I did here for down here for the first equation of 2 variables. And so this is going to be 4 times equation 1 plus equation 2 will yield equation B. And this will be in 2 variables since we're eliminating Z. We've chosen that. So I'm going to distribute this 4 amongst each, and I'm going to rewrite it just like I did in the previous. So I'm going to put my little white line there, and I get 4 times 3 is 12x. 4 times 4 is 16y. 4 times negative 1 is negative 4z. And 4 times 4 is 16. And then for my yellow, 7x minus y plus 4z equals 4. I'm going to add these together. And so these are going to add together to give me green. Yes, today red and yellow make green. So let's go ahead and gather this up and add it. That way we'll say 12 plus 7x gives us 19x. 16 plus a negative 1y gives us a positive 15y. Negative 4z plus 4z gives us a 0z. And 16 plus 4 is 20. Now you'll notice 0z, 0 times anything is 0, and so this whole term goes away. And I am left with 19x plus 15y is equal to 20. That is equation B. You'll notice that equation A and equation B have no Z component. You want this to be true. You need at least as many equations as you have variables. Step 6. Now we didn't reach a step. I'm sorry, we did reach a step. It says go back and do 4 and 5. Step 7 we did not reach with the first in the first video, and that is now that you have one less equation and now you have one less equation and one less variable. In our case, we have 2 equations, 2 variables. Solve using the steps from 3 to 6, or steps 3 to 6, or by substitution. If you take a look at these two, and let's put them back to back, and I'm going to change them. Bring my part A down here. So I have 24x. I want to get them right next to one another so you can see it a little bit better. And B is 19x plus 15y equals 20. You'll notice that we don't have really nice numbers. We can't reduce these, meaning divide through by any particular number, because they don't all share a same factor. And so since they don't, solving for these or using substitution is going to result in fractions that are kind of nasty. And so I don't really recommend fractions. If I can help it, I'm going to keep small numbers. In this case, we're going to get large numbers, and fractions versus large numbers. In the case, I'm going to choose large numbers. I think I can work with them easier in my head than I can fractions, especially at these values. So let's go ahead and work through it. Now I'm going to use elimination, And so again, I'm going to kind of go back to step 3 and choose, only this time I'm going to be dealing with these two equations only. And so I need to choose a variable to eliminate, and I'm going to eliminate y. So eliminate y. You can eliminate x or use substitution. You'll get the same answer. To eliminate y, I need to get equal but opposite values. Since 19 and 15 share no common factors, their least common multiple is simply the multiplying 19 and 15 together. So up top, I'm going to need to multiply the top equation by 15, and the bottom equation I need to multiply by 19. One of these must be negative, because right now they're the same sign. I'm going to choose to make the bottom one negative. You don't have to make the bottom one negative, that's fine. You can make the top. It's not going to change your answer in the long run. So what I'm going to need now is I'm going to need my handy dandy calculator, because some of these numbers are going to be very large. And there's no real nice, easy way to do 19s typically. So I'm going to distribute. Equation A becomes 15 times 24, which is 360x. So I'm going to distribute. 19 times 15 is 285y, and that's positive since the signs are the same. And then 27 times 15 is 405. Now in B, I multiply through by this negative 19, and 19 squared is 361, but it's negative. 19 and 15 is 285, just like it was up top, except it's negative because the signs change. And then 20 times 19 is 400. 20 times 20 is 400, minus 1 is, or minus 120, 120 being a factor of 20, is 380, but it's negative as well. So if I want to write a little note to myself, I took 15 times A, and I added negative 19 times B. I never subtract. Never subtract, please, please, please. It tends to mess everybody's signs up. And my result is x equals something, because I've eliminated my y, so I have only x left. When I add these together, 360 plus a negative 361 is a negative x. 285 and negative 285 cancel, and 405 minus 380 is 25. Divided by negative 1, x is equal to negative 25. Now what I'm going to do with this is I'm going to take it, I'm going to put it back into equation B to solve for y. So a little note to myself, B, x is equal to negative 25. That means that 19 times negative 25 plus 15y is equal to 20. If you're familiar with the United States quarter, there are 4 quarters and a dollar. If I had 20 quarters, I'd have $5. I have one less, so I have $4.75. This is negative $4.75 plus 15y equals 20. I add $4.75 to both sides, plus $4.75. That eliminates. I like to call it elimination because it's more consistent that way. 15y is equal to 495. If we divide by 15, 495 divided by 15 is 33. Divide by 15 on both sides. 15 divided by 15 is 1. We get y equals 33. Now we have x and y. We need z. So let's go back to our original where we have x's, y's, and z's. And let's find an easy one where we can solve for z. And number 1 looks pretty easy. So let's go ahead and we're going to rewrite 1 down here. So our coefficients are 3, 4, negative 1, and 4. So if we zoom back down here before we forget, 3, 4, -1, and 4. And 3x, 4y, -1z, 3x, 4y, -1z, and 4. Okay, we're good. Well, now we take number 1, and we're going to make x equal -25 and y equal 33, and we're going to find z. So before I do this, I'm going to go ahead and solve for z. I'm going to add z to both sides. This is substitution, by the way, if you don't recognize it. That goes away. I have 3x plus 4y is equal to z plus 4. Subtract 4 from both sides. And now we have 3x plus 4y minus 4 equals z. Substituting in for x, I have 3 times -25 plus 4. Substituting in for y, I have 33 minus 4 equals z. And if you stick this bad boy into your calculator, 5 times -25 plus 4 times 33 minus 4. Be careful on the order of operations, please. Calculators are stupid. They will do whatever you tell them. They won't think about it. And it's very easy to make a calculator mistake. 53 is equal to z. Assuming that all of this happened okay, we now have our ordered triple x, y, z is equal to the ordered triple -25, 33, 53. The only way to check this to be certain is to take this answer, substitute all three values into each of the three original equations, and check to see that you get 4, 3, and 4. That's going to take a lot of time. I don't care to do it in this particular video, but that's how you check. That's the only way to be certain. And even then, you can still make calculator mistakes, adding, subtracting, multiplying, dividing mistakes, and then get a false negative. At some point, you just have to trust yourself you did it right. I hope this helps.